Welcome back to Random Tek. On today's episode, we're going to be looking at the Floppy ROM, which is a flexible vinyl that contains computer software on it. Why? Because it's random. Before we try playing the vinyl, let's go into a quick history of this all. Interface Age was a magazine started in 1976 by the Southern California Computer Society. This magazine was aimed towards the home computer user at the time, consisting of various articles and programs that the reader could enter into the computer to run. Most notable about this publication, though, was the Floppy ROM, which was included in select issues at the time. Much like storing and reading data from cassette tapes at that time, the Floppy ROM would hold a computer program pressed into a flexible vinyl. The end user would then play this audio into the computer to load the program with varying results. Interface Age ended up making a total of 5 of these floppy ROMs in the end, which contained 7 different programs as shown here. I ended up obtaining the last of these, which included 2 programs, the automated address program for the Apple II, and on the other side, a program for writing letters. For the address program, the code is also provided to the user. However, the same can't be said for the letter program. For those of you who are wondering, as I was, what the program does, apparently it allows the user to print out different sections of address which they can use as an outline on fabric to create it. The company that provided the designs, McCall's, actually still seems to be in business today and allows people to buy pre-made patterns and create their own clothing. According to the instructions, we are to play the vinyl and output the audio to a cassette tape, which the computer will then load from. This seems simple enough, but I will be recording straight to my computer via Audacity and bypassing the cassette part. So let's record the audio now. The first step I did was to actually clean the vinyl, as we wanted the audio transmission to be as clear as possible. The vinyl seemed a little uneven, so I added a few coins to help flatten it. I don't have my speakers on at the moment, but you can still hear the faint noise of the vinyl recording. Okay, it seems to have finished. Let's check out how it did. Looking at the audio file, it does appear that the audio came through and sounds like it as well. Now, since I don't presently own an Apple II, I am going to use an emulator instead. I ended up choosing Virtual 2 for the Mac. However, if you are using Windows, then Apple Win should do the trick. Now, before I actually attempt to load the data from the vinyl, I wanted to make sure that the emulator would indeed work as intended for reading in audio files. To test, I ended up going to ASCIIExpress.net, which hosts a large section of Apple II games and discs in audio format. I decided to test Asteroid. Here we can listen to the file and download it. Now this file is in WAV format, and according to the emulator, in our case we need it in uncompressed AIFF format. It says either 8 or 16 bits is supported at up to 64,000 Hz. But I decided to go with what they recommend of 8 bits at 16,000 Hz. Opening the file in Audacity, we can export it as such. So let's try and load this into the emulator now. We can simply load a new machine. I'm using an Apple IIe for this, and select the file to load. Now we can click Reset to enter into the prompt screen and type load. If all goes well, the game will start. And it looks like it did. Now let's try our vinyl audio file. Again, going into Audacity, I trimmed off the start and the end of the blank data and exported it the same. So will loading this work? No, it appears not. This seems to be a trend with these projects. I attempted to export the audio in different frequencies, both with 8-bit and 16-bit sample sizes, but that didn't work either. So I decided to re-record the vinyl again, as any imperfections could cause loading problems. After various attempts, I could not get it to work. Looking at the vinyl, it actually appears to have multiple tracks on it, separating each program. Now when I recorded the audio after the initial data was finished, the vinyl would just go into a holding loop and not move on to the next track. I guess that was supposed to be done manually. However, due to this being such a small vinyl with a very small track and no lead-in for the other tracks, this was not a simple task. I did get what I believe to be 7 separate audio tracks. Trying to load any of these tracks also caused an error message. Upon looking into this further, it appears that an additional device may be necessary. The floppy ROMs were apparently recorded in Kansas City Standard, a format that was introduced by another magazine, Byte. When using the KCS format, you would have to first plug your audio equipment into some device to decode the audio file into a format that the computer would understand. This is mentioned in earlier editions of Interface Age magazine, requiring users to have a Kansas City cassette interface. However, in my magazine, it makes no mention of this requirement. At this point, I decided since the audio isn't working, why not simply enter the programs manually? After all, the code is there. After entering the first program, I tried running it and got various error messages. Now I have never used BASIC before, so I had to look up the documentation for each error and attempt to fix it. However, while doing so, I ran into the discovery that on the Apple II, there were 2 types of BASICs used: integer BASIC on the original Apple II, and AppleSoft BASIC on the subsequent ones after. So let's try running this code on the original Apple II, which we can do by typing in E000G to enter into the compiler and then type in run after all the code has been typed. Okay, it looks like we got the program working. So what does it do? Well, apparently it allows the user to create their own pattern to print. This would be kind of neat, however there are 0 instructions on how to use it. If not for looking at the code, I would not have a single clue of how to proceed. But it looks like entering 0 brings up a menu to allow you to do various things. So let's first type 150, which asks us to choose a starting column and then enter in a message. We will also try printing a couple of $signs. So now if we type 0 again, it will ask us to enter in a file name to save. When doing so, it prints out a binary save command, I guess for us to enter in ourselves. At the moment, I am going to skip this save command, as the data should still be in memory. Let's now enter in and run our second program. Running this program brings up a menu of 3 options: load a pattern from a file, print a pattern, and the instruction screen, which describes how to create the dress from the printouts. Since our previous design we made should still be in memory, let's test out the print function. And yes, there it is, printed on the screen. Now the point of this program was to print to the printer, which didn't happen. So I added a new line 90 to the code to send the data to the printer, which now shows up. With this working, let's now test the various programs that contain the dress data. You can enter these on the main screen of the Aperture and then run the program again to print. This is what we end up with. Now I believe the patterns are maybe off slightly, as it calls for a 132 column printer, and our emulator only emulates an 80 column printer, which was more standard at the time. So some lines are most likely overflown onto the next. Nevertheless, let's print out one of these designs to our StarWriter 2 printer. A little newer than what would have been originally used, such as the image writer, but it's the closest I have. So with this printout, I believe you would tack it to a piece of fabric and then cut or sew along the lines to create your dress. Now after all of this, there was a side 2 of the vinyl. This side contained a letter making program. While I did record the audio too, which sounded different yet again, I don't really know which machine this was made for. In the instructions, it says it contains 3 tracks, 2 of which are in Intel format, so I figure it must be for some microcomputer that used an early Intel chip, but I'm not sure which one and what emulator I would use to test, and I have a feeling that these are not working either due to being in the KCS format as well. And that concludes this episode. For those of you who are interested in looking at the data or the audio files, I've uploaded it all to archive.org. Thanks for watching, and we'll see you next time.